Okay, guys, in this video we're looking at rational functions that graph to have oblique asymptotes. Okay, so there's some things that we should be able to tell straight away. Number one, that this function is top heavy, right? We have an x squared on top and just an x on the bottom, so the function is heavy. So we've already seen some top heavy functions that graph to either lines or asymptotes with a hole in them, right? Those were all top heavy. So if it's a top heavy function, that means that there's no horizontal asymptote. Okay, so we could either have no asymptotes, or we could have, well, a zero, I guess, well, it depends. But let's see what's going on here. Let's first start with your r, right, finding your roots. That, of course, comes from your numerator, x squared minus 2x minus 8 equals 0. So we always find our roots by setting your numerator equal to 0. This is a factorable quadratic. What numbers multiply to give us 8 and add to give minus 2? That would be a negative 4 and a positive 2. So x minus 4 and x plus 2 are your factors of x squared minus 2x minus 8. So we have x-intercepts of positive 4 and negative 2. Okay, so let's go ahead and put that on a graph. We'll leave that over here. We'll make the graph to the left today. No reason why, but we're going to have an x-intercept at positive 4 and an x-intercept at negative 2. So we mark our graphs with tick marks, and you go 4 units to the right, and you go 2 units to the left. Okay, now let's move over to A, your vertical asymptote. That, of course, comes from your denominator. We set your denominator equal to 0. So we have x equals 2. So we're going to put a vertically dashed line through x equals 2 and go all the way up, way off your grid as far as you possibly can for these types of graphs. Okay, so notice the ones that we had done before, we could factor the top and the bottom, and we sometimes had an intercept where there's an asymptote, right? In that case, we could factor and simplify, and we would get either a line or a basic rational function. Notice here, we can factor and solve, but the intercepts and the asymptotes don't match up. So this is how we know that there's going to be an oblique asymptote, not something of another form. Okay, so we're going to skip the table for a minute and go to the E, which is not an E anymore. This is going to be an O. Okay, so because it's going to be an oblique asymptote, we're going to write O instead of E. O for oblique. Okay, and oblique means side. Okay, in your body you have something called your oblique abdominal muscles, and they are on the sides of your muscles that connect your rib cage to your pelvis, right? They're your obliques. So they're on the side. So oblique means, well, sometimes they're called slant asymptotes because they're slanted. And we find the equation for this by doing long division. Okay, so we're going to do some long division in order to find the equation for your slant asymptote. Okay, and for us in this class right now, they're always going to be linear. It's always going to be a y equals mx plus b. Okay, so we're looking for a linear equation that's going to come up and be your slant or your oblique asymptote. Okay, so let's see how we do that. You take your denominator, x minus 2, and you put your quadratic of the numerator, which was x squared minus 2x minus 8, inside of your box. The first thing we ask ourselves is, what do I have to multiply x, right? This x on the outside, what do I multiply that by to get x squared on the inside? Okay, so what do I multiply x by in order to get x squared? And the answer is x. So I'm going to put an x above my x column, right? So I have a column with x already below, right? The 2x is right here. So all of our x's will line up right there. Okay, and then we multiply. We do this. We do x times x minus 2. Okay, we distribute into both things, giving me an x squared minus 2x down below, right underneath with our long division. Okay, and now we subtract, right? The key to this is we subtract. So x squared minus x squared, that term is gone. Negative 2x minus a minus, so that's a plus, is 0. Okay, and then of course 0x, and then we can drop down the minus 8. But for ours and this problem, that's not important. We're basically done. This is going to be the equation of your oblique asymptote. Simply y equals x. Okay, so this is the equation of your oblique asymptote. We'll do another example where it's going to be more intense. But for the most part, that's what we're going to do. Okay, you're going to stop when you get an equation, like maybe x minus 2 or x plus 3, right? Whatever we have to do, but you stop once you get a linear equation. So that's going to be your oblique asymptote. We come to our graph, and we do a y equals x graph. Okay, so that graph starts at the origin and goes 1 up and 1 over. Right? It has a positive 1 slope, so you go 1 up and 1 over until you run off of your graph or your grid. Okay, so we are plotting the points for our y equals x. And then we're going to come in with some dashed lines like we do with asymptotes. Okay, so this is an oblique asymptote. Y equals x, okay? A slant asymptote, oblique asymptote. All of these graphs that are top heavy, right, that don't factor and cancel to something simpler are going to have a graph that looks like this. Okay, you have a vertical asymptote, and then you have some kind of a linear slanted asymptote. Okay, so excellent. There we go. That's almost done. Now we go back to your y, right? We find the y-intercept. I'll do that up here. That would be 0 squared minus 2 times 0 minus 8. So we're plugging in 0 for all the x's. Anytime we're finding a y-intercept, we plug in 0 for all the x's. Negative 8 divided by negative 2 is positive 4. So we go up 4 on our y-axis, 1, 2, 3, 4, and we put our dot representing your y-intercept. So finally, what does this graph look like, right? That's our final thing, is to actually make a sketch of the graph. Well, it can't cross your vertical asymptote, and it can't cross your slant asymptote, which means the right side of the graph is going to look like this. Okay, very, very smooth. Sorry, I hit a bump in the road. Very smooth. It's going to slightly curve towards your slant asymptote, and it's going to go down on the right side of your vertical asymptote. Okay, so they're still smooth curves like our rational graphs usually are. And then on the left side, we're going to come down from your vertical asymptote and go through positive 4, go through positive 2, and then head out towards your slant diagonal asymptote. Something like that. Okay, so yes, these are new. You probably haven't done them before or haven't done them in a while, and the long division might be kind of sticky, but that's why we're going to practice some, right, so to get you a little bit better at it. Okay, let's look at this example, okay, because there's two different types of graphs that happen with oblique asymptotes. Okay, this is the second type of a graph. But we'll start with our R. Okay, figure out where your x-intercepts are by setting your numerator, our quadratic, equal to 0. Okay, so that's what we do first. So let's factor that. I'm going to pause the video and factor it, and I'll be right back. This factors to 3x minus 2 and x plus 1. So my solutions are positive 2/3 and negative 1. Right? So we add the 2 to both sides and divide by 3. That's how we get 2/3. And then we just subtract the 1 from both sides. That's how we get negative 1. Okay, so let's come over here and make our graph. This crosses at 2/3, which is slightly less than 1, and crosses at negative 1, which is exactly at negative 1. Now let's look at your vertical asymptote, right? The A part, your vertical asymptote. We set your denominator equal to 0. So we have a vertical asymptote at +1. Okay, so real close to your 2/3. Now we have a vertically dashed line going through +1. Okay, so make it go all the way off your grid. However big your grid is, or your X or your T or whatever you got, make it go all the way up there. So because nothing cancels and it's top heavy, we know that there's going to be an oblique asymptote. So we cross off your E and we write an O for oblique. Okay, and then we get to doing our long division. So x minus 1 goes on the outside, and 3x squared plus x minus 2 goes on the inside. Okay, 3x squared plus x minus 2. And now we think in our brains, what do we have to multiply x by in order to get 3x squared? Okay, what are we multiplying x on the outside by in order to get 3x squared? And that answer is 3x. Okay, if I multiply 3x times x, I get 3x squared. And if I multiply 3x by 1, I get minus 3x. Okay, and the procedure is to subtract when we do your long division. Okay, we subtract. So 3x squared minus 3x squared, right? That is a 0. But then what is positive x minus negative 3x? Okay, that's a 4x. Okay, minus a minus is a plus. And then we can drop down the minus 2. Okay, so then my question once again becomes, what do I have to multiply x by in order to get 4x? Right? I'm multiplying the x on the outside in order to get 4x. I have to multiply by 4. So because it's a positive 4, I put a plus 4 up there. Okay, now if we wanted to, we could multiply by 4 and you could figure out what the remainder is. But you know what? We really don't care because we want to have our linear equation. Okay, with that plus 4, we have now made our linear equation, and this is going to be your oblique asymptote. So let's take that equation to our graph, 3x plus 4. Okay, so it has a positive 4y intercept, positive 4y intercept, so we go 4 units up on our y-axis, and then we go from here down 3 units and left 1. Down 3 units, left 1. Down 3, whoops, I'm running out of space here. 3, left 1. Okay, in addition, we go up 3 and right 1. Up 3 and right 1. Okay, and if you have an actual grid on your paper, your slant asymptote might actually look like a line. Mine, maybe not so much. It's got some curvy curves in there. A little bit of wobbling, but such is life when we're graphing on freehand. That's okay. Okay, so we still have this slant asymptote intersecting a vertical asymptote. Okay, on to your, what else we got? Your y. Where does it cross your y-axis? So 3 times 0 squared plus 0 minus 2 over 0 minus 1, and we get positive 2. So it's going to cross here at positive 2. So remember, our graph can't cross our asymptotes, right? It can't cross your vertical one and it can't cross your slant asymptote, but it has to go through your 3 points. Okay, so our graph is going to look kind of like a boomerang, I guess, for lack of another different descriptive word. A boomerang will come next to our blue line, right? Hit -1, come up to positive 2, make a curve, and basically go straight down towards your yellow line. Okay, now remember, all of these have symmetry. So not only does it exist down there by your origin, it's also going to exist up here in a very similar manner, right? Very reflective, very mirror-like. None of our processes tell us about these points up here. Okay, but you just need to remember that all rationals have this reflective property across their asymptotic intersects. So you have to just remember to put it up here for the second part of your graph, but all of your equations tell you about this part down here. Okay, so these are your two different types of graphs that we get when we have rationals with top-heavy slant asymptotes. Okay, we either get ones that are sweeping to the left and the right, go outside of your x, or we have ones that go on the inside of our x and that look like boomerangs or parabolas. Okay, those are your two different graphs for slant or oblique asymptotes.